Hey guys, so this video is just a video going over the solutions to the questions we looked at in class last Tuesday. So this will be a good review for your test, which is on Wednesday. Feel free to skip through this video, pause whenever you need to. Otherwise, let's get started with these questions. So this first question here is asking us to determine if ABCD is a parallelogram. So let's look at what the solution would look like. So if you draw a rough sketch, now remember, you don't actually need to draw a sketch if it doesn't ask you for that. And wow, those lines are really tricky, but that's okay. So we have point A is -2, 1. Point B is 3, 3. C is 4, -1. And D is -1, -3. So we stick those on as maybe somewhere around here. Okay. B is maybe up here somewhere. C is about maybe there. And D is there. So as you can tell, this is a very rough sketch, but it gives you an idea of what you're looking at. Okay, so we have that. So now, if you remember, we can check if something is a parallelogram. We can check if our slopes of the opposite sides are the same. So we have to check if the slope of AB is equal to the slope of DC, and we have to check if the slope of AD is equal to the slope of BC. So let's do that. So if we do slope AB first, we get remember that's our formula for the slope. And now if I go ahead and calculate all these, we could get, so we have the slope of AB and DC is both 2/5. So then we can say that that those two lines are parallel, right? Because the slopes are the same. Now if we do the same thing for lines BC and AD, we get that the slope is -4 for both of these lines. So again, that means, and then that's all we have to do. Now, all that's left is our therefore statement. So in this case, we would say that since oh shoot, that's not what I want to do. We want slope AB is equal to slope DC and slope BC is equal to slope AD. AB is parallel to DC, and these two like slanted lines are what I use the short form for parallel. And DC is parallel. Oh no, wait, I just did that one. Not DC. BC is parallel to AD. Then, therefore, the quadrilateral ABCD is a parallelogram. Okay, so that's the first question done. The next question asks us to figure out where the diagonals intersect. Now this is the same parallelogram as the last question. And if you remember, properties of diagonals and parallelograms the diagonals bisect each other and they intersect at the midpoint. So all we have to do is find the midpoint of our diagonal. So we want the midpoint of AC is you know the midpoint of AC is 1, 0. Now, we could go ahead and calculate the midpoint of BD, but we know that the property of parallelogram says that they bisect each other. Now, if this said verify that the diagonals intersect, we would have to check the midpoint of DC. But since we can just make use of this property, we only need to find the midpoint of one of the lines. As we know, it should be the same for both of them. So we're actually done now, and we can just do our therefore statement. So you just say the diagonals intersect at the point 1, 0. Okay, and then our next question is the exact same thing because we're just looking for a midpoint. So again, we only have to calculate one midpoint instead of two. And if we do that, we get 5, -1 as the midpoint for both. So we say the midpoint of AC and BD is just 5, -1. Okay, then we can go on to our next question, number 4. Now we have to classify what quadrilateral we have. So this is where we've got to find our slopes and the lengths of our lines to check what's happening. So let's do the lengths of our lines first, because that's probably the longest part of this question. Okay, so let's start with length BC. And as we go through this, feel free to just skip ahead right to the answer if you got this stuff. If not, then feel free to follow along and write all the steps down. That was BC, and then AD. Hold on, I think I screwed that number up. Let me double check. Yeah, so that's maybe we should just do -6 again. Okay, so I was supposed to negative. I read that wrong, sorry guys, but you should get 9 plus 4 again in the middle. So this is 15. And remember that if this was a radical that you could reduce, that you would have to write it in most forms. here we found out that all four lengths are the same. So we can say that it's got to be at least a rhombus. But we don't know if it's a square because we haven't checked the slopes yet. So at this point, I would say since AD is equal to BC is equal to AB is equal to CD, our quadrilateral ABCD is at least a rhombus. We have to double check if we've got a square or not by looking at the slopes. Okay, so now let's look at the slope of AB. So that's going to be 0, get 1, and the slope of BC is going to be 3 minus 1. And that is -2 over, oh, sorry, not over, but the answer is just -2. Whoops. -2. So our slopes are different. That means it's not a square, but it still is a rhombus. Okay, so we can then do our overall therefore statement. So since MAB is not, well, I guess we want to say it's not equal, but I would say it's not the negative reciprocal, that's what I'm saying. So now I split up my therefore statements in two separate sections, but you could also write one overall therefore statement that would look something like this. You would say, since all the lengths are equal, and the slope of AB is negative reciprocal of slope BC, quadrilateral ABCD is a rhombus. Okay. So that was the entirety of question 4. Long one, I know, but that's what you need to do in order to classify a quadrilateral given 4 points. And then our next question, whoops, I don't think we got to this when we were in class. We about ended here, but there were a few questions that we didn't see in class that I had prepared just in case we got that far. And then this was question 5, so it's asking us to see if the diagonals in the rhombus ABCD bisect each other, and if they bisect each other at right angles. So in order to check if they bisect each other, we have to basically check if the diagonals split each other exactly in half. So if you remember, we're basically again checking same thing we did in question, I think it was 2 and 3, where we found the midpoint. We want to do the exact same thing here. So now we have to check if AC and BD have the same midpoint. So let's go ahead and do that. So we have midpoint Wait, hold on. I think I screwed up the points. Let me double check this. Okay, sorry about that, guys. I had a moment where I was reading the points completely incorrectly and it wasn't making sense. So we have the midpoint of AC is going to be -8 plus -8 over 2 and 7 plus 1, 2. And that's going to give us midpoint of BD going to be we get the same thing again, right? Negative 6 over 2. So we get -8, 4 as our midpoint for both of our diagonals. So we can say our therefore statement. We're done. So since AC and BD have the same midpoint, they bisect each other. Okay, so now let's check the second part of this question. Now, to do that, we'll have to find the slopes, right? Because if they intersect at a right angle, then the slopes will be negative reciprocals. So the slope of AC is going to be just 6 over 0. So that means our slope is undefined, right? And we know that lines with slopes that are undefined are vertical lines. Okay. Then let's check the slope of BD. And the slope is 0. So we know that lines with slope 0 have to be horizontal lines. So that means both AC and BD are perpendicular because one's vertical and one's horizontal. So in this case, we can go ahead and write our therefore statement. So since AC is a vertical line and BD is a horizontal line, AC is perpendicular to BD. And this sort of symbol here is the short form I use for perpendicular. It's just basically a right angle. And that's exactly what we wanted to prove. we're done this question. And then our next question was this one. So it's another classified question. So this time it'll obviously be something different, but you never know. So you always have to check everything. So let's go ahead and do our lengths and our slopes. So for this question, I'm just going to show you the answer directly without going through all the steps by talking through them. So here are all the lengths. So AB is root 8, AD is 2 root 5, BC is root 8, and CD is 2 root 5. So we've got two sets of opposite sides being the same length. So that means it could be either a kite or a rectangle if we have two of those. But let's double check with our slopes. Or I mean, not with our slopes, but a diagram to help us see where our points are. So we draw our diagram in. So A is somewhere here. B is maybe up here. C is maybe over here. And D is about right there. We connect those dots. From our lengths, we know that AB and BC are the same, so these two are the same, and that AD and CD are the same. So two sets of sides are the same length, but they're different. This can't be a rectangle because we need the opposite sides to be the same. So all it can be is a kite, because a kite just needs two sets of side lengths that are the same. So you can write in our therefore statement. So since AB is equal to BC and AD is equal to CD, let's see, D, ABCD must be a kite. So now this last question is another classified question. I know it's a lot of practice for this type of question, but it is nice to go through all of these steps as it covers pretty much everything we've done in this. So again, for this question, I'll just show you the final answer at the end, since we are going through the same steps. Okay, so I found that the length of AB, BC, CD, and AD were all root 8. So since all the lengths are the same, ABCD has to be at least a rhombus. But again, we have to make sure if it is a rhombus or not by checking the slopes, because it could be a square. So here we found that the slope of AB was 1, and sorry, not BC, that, okay, I just realized I calculated the wrong slopes. Let me do that again. Okay, wait, no, I did calculate the wrong slopes. Sorry, I'm just going crazy. It's getting late. I spent the entire weekend moving. We're in the process of moving houses, so all the boxes and all the furniture, we did that yesterday and today. So I'm a bit tired. But yes, these are the right slopes. I was thinking diagonals again for some reason, but we don't care about the diagonals in this question. We just care about the side lengths. So yes, the length of AB is 1, or the slope of AB is 1, and the slope of BC is negative 1. So that means they're negative reciprocals, and they have to be perpendicular. So since that is true, and we have all the lengths being the same, ABCD has to be a square. Okay, so those were all the practice questions. And for Tuesday stuff. I hope you like this video, despite all of my mistakes that happened through it. If you did like it, let me know, and maybe we can do more of this stuff in the future. If you do, also let me know, because it's good for me to get feedback on this kind of stuff, or if you have any suggestions on things you'd like to see, or maybe, my writing is too messy, anything like that is also fine. Just let me know. Otherwise, have a good night, guys, and good luck on your test.